So in this video, we're going to talk about improper integrals, but we're going to talk about type 2 improper integrals. So these are integrals involving vertical asymptotes. So, okay, these are not as obvious. So what do these look like? So this would be a classic example. So why is this a type 2 integral? It's because you have 0. So 0 is clearly a vertical asymptote because if you try to plug 0 in for this function, the function does not exist here. So 0 is not in the domain because you can't have a 0 in the denominator of a fraction. So what do we do for this? How do you evaluate? So this is very similar actually to type 1 integrals. So if you have the function continuous everywhere except maybe on one of the endpoints, so if I have this set up kind of like the situation that I just showed you guys, so what you can do is you replace that number in your limits of integration that can't be evaluated. So let's say it was this. And so I'm going to replace it with a c, and then I'm going to have a limit as c goes to a on the right. And if you think about how that graph looks, so that's the only limit that's going to, like on this interval, we have to approach from the right to get to that number a, okay? And then if we go the other way, so now if I'm continuous on this interval where at the endpoint I am not continuous, it's the same thing. So I'm going to take that endpoint b where this function is not continuous, I'm going to replace it with a number c, and then I'm going to have the limit as c approaches b on the left, okay? And okay, so that's really it. And then the last one is, okay, so what if you have an integral that is discontinuous somewhere on the interval? So let's say my integral goes from a to b, but it's not continuous at c. That's what this is trying to get at. So it's continuous everywhere but c. So what you're going to do then is you break up your integral according to that point where it's not continuous. So then I break this up into two different integrals, and basically then I use the previous information to evaluate each one of these integrals. So similar to type 1 integrals, if the limit exists, then we say that the integral converges, and otherwise it diverges. So let's jump into an example. So let's use this example here. So I've got the integral from 0 to 3 of dx over the square root of 3 minus x. So for this one, where does this not exist? You might even want to pause if you want a second to think about it. So this does not exist at 3. At 3, I get a 0 in the denominator. That's bad. So what I'm going to do is I'm going to replace that 3 with a c, and then I'm going to have this limit as c approaches 3 on the left. And if you think about it, if you kind of remember some of the basic things from limits, which I think a lot of people forget this actually, is so any number, so this integral will only exist at 3 on the left. This integral actually does not exist at 3 on the right. So what that means is, what are some numbers to the right of 3? Something like 4. So if I plug in 4 for this integral does not even exist because it's not in the domain. We can't have imaginary numbers for when we're working with square roots and integrals. So 3 is actually kind of the last number that exists here for this domain, or up to 3. Obviously, we can't plug 3 in. Okay, so anyways, so now I just have to integrate this like, a regular old integral. So I've got to use substitution. So if you want, what I would recommend actually is that you try to finish this entirely. So I think you kind of know enough about limits and integration that you could probably make an educated guess on how to finish this. The worst that happens, right, is that you can't finish it, and then I'll just show you, but give it a try and then hit play when you're ready. Okay, so I set up my substitution. So you can see all my work here. So ultimately, when I integrate, I get -2 times the square root of 3 minus x. And so then I just need to plug in my limits of integration here. So I've got everything set up so I can evaluate my limits of integration. So here is really what I need to evaluate now after I plug in my c and my 0. Okay, so what I want to do is now I want to just focus on this calculation here. So here's the deal. Sometimes when you're doing these limits, actually, the limit calculation's pretty easy. So in this case, the reason why I need to set this limit up, this limit only exists from the left, but as far as how do I evaluate this limit, it's honestly as easy as just plugging in 3. So if I plug 3 into this, I just get 0. That's not a problem. So this whole thing just turns into 0 plus 2 times the square root of 3, so the answer is just 2 times the square root of 3. So a lot of these limits can be straightforward to evaluate, which is nice. Okay, so let's try another one. So for this one, I've got the limit from -8 to 1. of 1 over x to the 1/3. So what I want you to do is I actually want you to think about where doesn't this limit exist? And then based on that, how would you set up the integral? So we've talked about this enough that I think you could set this up. So let's see if you could just set up the integral and then hit play when you're ready. So this limit does not exist at x equals 0. So I need to break up my limits of integration then at 0. So what I'm going to do is I'm going to evaluate the first limit from -8 to 0, and then the second one from 0 to 1, and that will cover my whole interval. And so now I need to just go piece by piece. So what I would recommend here is, once again, let's have you just try it, see how you're doing with this. So evaluate the first integral entirely on your own, and let's see what you get, and then hit play when you've got it. So I'm going to just focus in on this integral. So I set up my limit here, so it doesn't exist at 0, so I'm going to have the limit as c approaches 0 on the left. So now I can go ahead and just evaluate this integral. So what I get is that this is going to be 3/2 x to the 2/3, and then I can plug in my limits of integration. So plugging in my limits of integration, this actually is not too bad of an integral to evaluate again. So I've got this limit here that I need to evaluate, but I can really effectively just plug in the 0 for this one. This is a easy peasy integral to evaluate. And then here I've got to evaluate what to do with that -8. So this will turn into, this is 0, so this limit just equals 0, because I can plug 0 in. It's not going to cause any issues. And then for this one, so this becomes 3/2 times +4. And so 3/2 times +4 will give me -6, or sorry, this will be minus and then 6, so 0 minus 6. So the whole answer here will be -6. So this first part is -6. And so now we've got to evaluate the other side. So again, if you didn't get the first one right, what I would say then is just try this one on your own. Either way, I think you should try this one on your own and then hit play when you're ready. So I'm going to go ahead now and evaluate the other one. So plugging everything in. So I set up my new limit. So again, doesn't exist at 0. So now I have to have the limit approaching 0 from the right, but the work is very similar, right? So it's still the same antiderivative, and then I can just plug everything in. And so now in plugging everything in, this will turn into 3/2 minus this limit here will just equal 0. So I'm left with 3/2 minus 0. So this particular integral just equals 3/2. So now this is what I need to add up together. And so this will give me -9/2. And so that is really the gist of what you need to do for type 2 integrals. So I have other examples on that, or if you have other examples that you want to see, you can always leave me a comment. I love it when you guys hit the like button or the subscribe button, and otherwise, I will talk to you guys in another video. Bye!